The human desire to engineer an escape from the heat is age-old. From ancient Rome's aqueducts to India's chilled palaces, our ancestors displayed remarkable creativity in cooling solutions. The quest ultimately culminated in Willis Carrier's invention of modern air conditioning in 1902, revolutionizing architecture, industry, and society. Our tale is one of relentless human ingenuity to make the world a cooler place. The urge to escape the heat is universal. Long before mechanical cooling, our ancestors improvised ways to moderate scorching temperatures. Indigenous Australians took shelter in branches and mud. Aztec dwellings had canopies for shade and evaporation, and Egyptians slept on rooftops to catch the night breeze. Both the Inca and Indus Valley civilizations built air tunnels ventilated by convection. While not true air conditioning, these intuitive methods leveraged architecture and nature to survive in harsh climates over millennia. The spark of innovation to control our environment was primal. The earliest air conditioning took shape as Roman aqueducts around 312 BC, with water flowing through pipes and villa walls carrying away heat. Similar hollow wall designs later appeared in India, Persia, and Egypt. Early Middle Eastern dwellings had wind towers to funnel breezes inside, while traditional houses in India, Pakistan, and the Middle East employed jalousie windows, earthenware pots, and circulation towers to produce cooling airflow. The 2nd century Chinese inventor Ding Huan pioneered rotary fans powered by wheel systems and water. In 747 AD, Emperor Xuanzong of Tang had the Cool Hall, built in Beijing, employing water-powered fan wheels to circulate air over collected cedar fronds as an early form of evaporation cooling. Meanwhile, the medieval Middle East saw extensive use of wind catchers and tall hollow towers to funnel air downward into homes. Arabia's desert climate drove creative solutions like underground irrigation channels to chill dwellings. By the 1700s and 1800s, scientists and engineers sought more advanced and refined cooling methods. Benjamin Franklin and Michael Faraday studied the physics of heat absorption and refrigeration. Innovators experimented with ethyl ether compression to generate chilling, and Faraday achieved the first ice-based cooling in 1820s in England, while American inventor Thomas Moore patented a compression refrigeration system in 1860, paving the path for modern air conditioning. He launched a fervent quest to control temperature and humidity through mechanical means. David Reed patented an evaporative cooling in America in the 1860s, increasing airflow with fans passed over steel coils cooled by water as chilled air flowed down ducts into living spaces, not unlike the early Roman inventions. These pioneers understood that cooling, dehumidification, and air circulation were interlinked. Perfecting this combination through increasing technological sophistication became their driving obsession. The late 1800s saw a burgeoning patent race across America and Europe to crack the code on creating cool, breathable indoor air. The breakthrough was just over the horizon. In 1902, a young American engineer named Willis Carrier developed the technology that became modern air conditioning, while attempting to solve humidity control issues in a Brooklyn printing plant. Carrier created the first system to precisely cool and dehumidify interior spaces. This revolutionized industrial manufacturing processes. Reliant on regulated environments like textiles and munitions, Carrier founded his own company in 1915, installing his design in theaters, stores, and office buildings. But uptake was slow due to the technology's expense. The 1909 invention of Freon refrigerants by Thomas Midgley made cooling more affordable and compact. By the 1920s, mechanical methods had arrived, and their use expanded rapidly from the 1950s onwards. While wartime manufacturing popularized systems that kept spaces cool for enhanced productivity, post-war prosperity increased consumer demand for household comforts. Large, centralized plants cooled groups of buildings through ducted air distribution. It was during this time that it had graduated from industrial innovation to social necessity, enabling a sweeping reimagination of architecture with styles like modernism and brutalism emerging in the early 20th century. Soaring glass-faced towers rose on the back of air conditioning systems, keeping interiors cool and open layouts functional. It's become central to urban design. From offices and factories to homes and cars, it permeated society, while allowing cities to expand into hot climates like the deserts of Arizona or Arabia. Of course, this ubiquity has an environmental cost. Energy use, pollutants, and climate impacts of our vast cooling infrastructure are substantial. If anything, the demand grows, and engineers constantly work to refine efficiency. Now, it's not only cooled indoor spaces, but reshaped outdoor environments as well. By making hot and humid climates more inhabitable, it enabled migration toward warmer regions of America like the Southwest and Southeast. Sunbelt cities like Houston, Miami, and Phoenix boomed after World War II, and their expansions, underwritten by cooling, allowing people to live comfortably in these harsh conditions. However, the greenhouse gas emissions from vast amounts of electricity needed to run air conditioners increased substantially. Our use of hydrofluorocarbons and other refrigerants also raised concerns about ozone layer depletion. With air conditioning consuming over 6% of all electricity produced in the United States, the environmental impacts add up to expanded carbon footprints. At the same time, it's produced us many benefits by preventing deaths from heat stress and improving health and productivity. Alternatives like passive cooling or shifting populations are unlikely to replace such benefits currently. So more realistic options involve focusing on renewable energy sources and phasing out hydrofluorocarbon refrigerants. But air conditioning's environmental paradox will likely persist. The lightweight, inexpensive construction of modernist skyscrapers relied on mechanical cooling and ventilation to make their sealed towers habitable. The international style of boxy glass edifices took hold from the 1950s onwards. Air conditioning birthed an expansive modular architecture of open plans and floor-to-ceiling glass. It enabled radical experiments in minimalist forms like Eero Saarinen's TWA terminal at JFK Airport. For better or worse, this machine enabled aesthetically transformed cityscapes worldwide. This monumental invention is built upon a centuries-long lineage of thermal innovation, and in its modern form represents an engineering apex in perfecting the factors of controlled environments. Refrigeration transforms society. Our cities, homes, vehicles, and workplaces would function radically differently without it. Air conditioning's implications remain complex and far-reaching, but one thing is certain: there will never be a shortage of demand for that blast of cool air amid the swelters of summer.